What did you get, Charlie Brown?
I got a rock. I got a rock. Rock. I got a rock. 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 I got a rock. I got a rock. I got a rock. Rock.
What did you get, Charlie Brown?
I got a rock. I got a rock. Rock. A rock. I got a rock. I got a rock. Got a rock.
What did you What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock. Got a rock. 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 I got a rock. I got a rock. 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 I got a rock. I got a rock.
All right, so today we're just going to continue on strings. It was announced that the C version of last night's lab is extended until midnight tonight due to the Eastern Seaboard outage in GitHub, right? So it was an entire regional kind of thing. So we left off talking about byte-limited versions of basic operations, copying, string concatenation, the C-type library that allows you to operate on single characters instead of just strings. We then moved our focus over to strings in Java, where things were much easier because all you need to do is concatenate things together using the plus operator. You don't have to worry about memory management in Java, so if you want to create a new string, you just create it, right? However, remember that they are immutable. Once created, you cannot change them, so you have to use them correctly. If you want an all uppercase version of something, for example, full name dot to uppercase, right? That does not change the string, right? The string is unchanged. Instead, it creates a new string that's an uppercase version of the old string and then returns it, and you have to capture that in a variable, right? Foo, right? You have to do something like that, okay? Then we went on to see that there was a mutable version of a string in Java called String Builder that you can iteratively build on it. You can change its contents. You can append to it. You can do whatever you want with it through its methods, right? Appending, replacing, et cetera, until you're finally built the string, and then you can dump it to a mutable string if you want, okay? We also looked at string comparisons, where in neither language will the equals equals operator work. You're not going to get a warning. It's not a syntax error, nothing, right? Instead, you need to use strcase-cmp, strcmp, strncmp, whatever you're wanting to do in C. And then in Java, you do the same thing, except that you use compare to. It's a comparator pattern. It returns something negative, 0, or positive, depending on the relative ordering of the elements, A and B. If they're in order, negative. If they're out of order, positive. If they are in order, if they are equal, then you get 0. Right? Okay. Otherwise, let's go ahead and continue now on other operations that you can use in both languages. So first of all, string formatting, right? In C, you can use printf to printf. I spelled that right. All right. To format the output to the standard output. Remember, the standard output is the screen or the terminal or whatever. You can also use sprintf. What do you think the S stands for in front of it? String. To print, and I'll put that in quotes here, print to a string. Right? So you're actually printing to a data buffer, but since data is strings, right, then you're printing to a string. Here's how it works. Let me go ahead and come over here and create a couple of variables. I'll just go ahead and cut and paste these, right? And I'll call this formatted. There we go. Let's change the name to School of Computing, just to have some variety here. So I've got an integer, I've got a double, I've got a name. We know how to format those with respect to printf, right? If I wanted to print these out, what would it look like? Printf, A is equal to %, the placeholder for an integer is going to be D, right? B is equal to, what's the placeholder for a floating point number? %f. And if you want to manipulate it, you can go ahead and add, 10, at least 10 columns and only 1 digit of accuracy, right? Decimal of accuracy, excuse me, right? And then the name is equal to %s, and the line, right? You can put tabs, you can put whatever you want in there, like you would with printf, right? So A, B, and name. Now, if I just ran this, it would print to the, come on. GC, ooh, come on. All right. Kill that terminal, open up a new terminal, and hope that it works. Oops, okay. New terminal. Get rid of, oh, I don't know how to get rid of that, so I'll just leave it. All right. All right, GCC demo. Right, now this will print it out to the standard output, right? 42, and then I've got a lot of space in there because I said I wanted at least 10 columns and School of Computing. But that dumps it to the standard output, right? What I want to do is I want to dump it to a string, in this case, formatted. Right? So I'll use sprintf instead. Now, it does take a new first argument, the string that you want to print to, so formatted, right? And then, otherwise, it's exactly the same. Right? Now, if I compile this and run it, you'll see that it won't actually output anything to the standard output because I'm no longer printing to the standard output. I am printing to the string formatted right here. Let's go ahead and print that out to the standard output. Printf formatted equals %s and the line, and formatted. There we go. GCC, run this again. In fact, let's clean this up and run it again there. All right. You see that the contents that were normally printed to the standard output are now printed to the string itself. Why do I have an extra space in there? When I formatted the string, I had one end-line character. When I print the string out, I have another end-line character. So if you're doing string manipulation, if you're doing data processing and you've got a lot of end-line characters, maybe you need to remove those or something, right? Maybe you need to think about how to should this have an end-line character? Should it not have an end-line character? Do I need to trim that out? We call that chomping, and we'll take a look at an example here in a moment. Right? So here's how you can print to the standard to a string instead of the standard output. Can you do that in Java? Let's find out. So everything is going to be the same up until, of course, strings. Right? String name. It's going to look something like that. Okay. Now I'm going to go ahead and get rid of that because there is no printf, right? There's system.out.printf. So let me go ahead and keep that, system.out.printf. Right? But there is no sprintf. Instead, there's something very similar to it, but it's in the string class, right? Like all of those library functions. It's going to be in the string class, and it's not called, unfortunately, it's not called printf. It should be, right? But it's called format, right? And the format that you want to use is exactly the same. The placeholders are exactly the same. The arguments are exactly the same. Except that I'm not printing to a string here anymore. What it's doing is returning a string. So string formatted is equal to this. Right? Why? Because, again, in Java, it's not my responsibility. Right? It's Java's responsibility now to take care of the memory management, to make sure that the character array is big enough to hold whatever it needs to hold, take care of any null terminating characters. There are no null terminating characters in Java, but you get the idea. Right? Now let's go ahead and run this. And, oops, always forget to save, damn it. Right, there we go. There we go. Right, exactly the same as C. So here is the Java version. It returns a string instead, and it's called a string.format. In Java, you use string.format instead. Right, so here's the Java block. There you go. All right. Okay. Let's see. Before we move on to the next one, let's go ahead and do some exercises. Right? So, for example, remember I was talking about, well, when you're doing data, you may or may not want n-line characters everywhere, right? So one common operation is called trim, right? Trim, or sometimes we call this chomp. Right? So what I want to do is I want to write a function, say in both languages, to trim out leading and trailing white space. So what I want to do is this function takes a string and removes all leading white space, all leading and trailing white space. Sometimes it's L trim and R trim so that you can trim it on the left, trim it on the right, and then trim is doing it on both. Right? So trailing white space from it. Right? So in other words, it's going to change that string. So am I going to be returning anything here? Probably not. We could make this a void function, or we could make it into a function that does error handling. Let's do that. I'm going to take a string. Can I take a string like this? Const char star s. Right? Const, what does that do? It says I'm not going to be making changes to it. But that's what I'm doing. I'm going to be making changes to it. So I don't use const here. Okay. So what I need to do is I need to trim trailing. Let's do the easy thing first. Well, yeah, let's do, what do we always do in any function first? Error handling. So what's the only thing that could happen here that we could detect? If it's null, right? Then return a non-zero error code. Right? Return 0 if everything was fine. Right? So error handling out of the way. Okay. Could we possibly do error handling to check to see if it was not properly null terminated? Not really, right? If somebody didn't null terminate the string, how would we determine if it's null terminated? We'd start at the beginning and go until we get to the end. How do we know that this memory belongs to us or not? We don't. Right? There's really no way to check that. If there were a way to check that, then all the built-in string library functions would be doing that. Right? Unfortunately, that's not the case in C. Right? So let's go ahead and take care of the easy thing first. Let's trim trailing white space. ... So first of all, is there a tool that I can determine whether or not a single character, say S of 0, is white space? What? Over here in, or was it a long time ago? There were. is space in the C-type library. So let's go ahead and bring that in because we're going to start using it. C-type. Now you could say, well, okay, I only want actual spaces, or I only want actual n-line characters. Those are different, right? But is space will return true if it's a tab, if it's a space, if it's an n-line character. There are 3 or 4 of them, right? So is space is going to be our tool here, right? So trim trailing white space. So what I'm going to do is I'm going to start at the end. ... While the current character is, let me go ahead and align that over here. Start at the end. While the current character is white space, using is white space here, right? Then trim it out. So how could I trim it? If I had HELLO and then a space right here, right at the end, and then of course my null terminating character, right? How would I trim it out? How could I get rid of that last character? Say S of 0. What could I do to get rid of that character? Like end the string right there. What ends a string in C? The null terminating character. Right? So let's go ahead and translate this all to C and then get rid of all of our comments. Start at the end. What's the last index of a string? Int n is equal to, if it's HELLO, it's 5. So 5, 0, 1, 2, 3, 4, 5 minus 1. What do I need to do to get that 5 first if it's hello? How do I determine if it's, what the length of a string is? str len, right, of s. Right? And then I'll create an index variable. Int I is equal to n minus 1. Again, why minus 1? Because you start at 0. 0, 1, 2, 3, 4. So if there are 5 characters in it, you start at index 4. Right? And while the current character is white space, well, that's easy. While s sub I, the current character, is white space, right? Is space, s sub I will trim it out. Oops, ugly. There we go. Trim it out. So s sub I is equal to the null terminating character. Now, is there anything else that I need to do to set myself up for the next run of this loop? No? So I'm always ever going to be at one index? Right, this is the end of the string, right? I want to cut this character, I want to cut this character, I want to cut this character. What do I need to be doing? Moving forward. So I minus minus. Okay, we'll leave it like that for a second. Actually, let's test it before we move on, right? Ad hoc testing. Let's make sure that it works. So int test. And I'll just make a big giant string here so that I can change it, right? School of Computing. Space, 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 tab, 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 n line, n line, n line. Right? That's good. Okay. And let's go ahead and print it out. Printf test is equal to %s. This is just ad hoc testing here, right? It is a sanity check. Does this actually work? Printf after we, I call it trim test. There we go. Okay. Oops. Test. What are you complaining about? Not really sure. What am I doing? Char. Duh. There we go. All right. So again, there's a whole bunch of white space characters at the end, and it looks like that all those white space characters that we're printing but not visually, except for the n-line characters here, have been taken out. Okay. What if I put in an exclamation point at the end? Should we expect it to trim anything out? No, it trims trailing white space, right? So if there is no trailing white space, then it should leave the string alone. That's another test, right? What's another extreme test? all white space, right? So if it's all white space, then is it going to work? Find out. Looks like it. Let's find out if Valgrind is happy about it. Definitely. Oh, yeah, you are. Whatever. All right, I don't trust you at all. Right? Anyway, you know what? If I made you into a dynamic string equals int, or sorry, char star malloc 100 times size of character. There we go. And then I did strcpy into test this value. Now you'd better tell me that that's an error. Yep, there we go. Right? So why was it an error? If the entire thing is white space, walk through this algorithm right here. Right? Say that there's just 5 space characters. Right? Oh, that's a space character. I get rid of it. That's a space character. I get rid of it, get rid of it, get rid of it, get rid of it. Right? And then I keep going. Right? Past 0 here. So this is not the only thing that I need to make sure that this loop is correct. If I go all the way to 0, I don't want to go to -1. So what else should I be checking here? I is greater than or equal to 0 because it's okay if it's 0, right? We might need to take care of that one. And, oops, there we go. And it's a space. Now, that extreme test case there where it was all white space, well, no, that error is because I'm not cleaning it up. Fine. Let's go ahead and clean up after our tests, free that test string. Okay. Valgrind has 0 errors now. Right? We only knew that because we ran Valgrind, right? So when it works locally on our machine, and then we upload it to a more sophisticated machine that is really trying to break stuff, chaos testing, fuzzing, right? Fuzzing is trying to give it bad input to try to break it, right? Then it suddenly breaks, right? And we never saw that because we never ran Valgrind to see that there are lots of errors, right? Okay, so that's trailing white space. In fact, wait a second. I could go ahead and put this into a function called rtrim, right? And then I could take care of another function called ltrim, right? Trim leading white space. And then all I would have to do is combine those two things and have my trim function that I originally wanted. I'll let you do that as an exercise though. Let's go ahead and take care of the other part, right? So trim leading white space, ... Ugh. Okay. And I don't know if this is going to come across on the live stream here, but let's go ahead and think about it in terms of, you know, some spaces here. Usually we use this symbol here to denote a space, right? So that you can actually see something, right? So if there's a space, a space, a space, and then hello, right? 1, 2, 3, 4, right? And then end line, or null terminating character there. What I want to do is I want to shift everything over by 1, 2, 3 spaces there, right? So ideas on how to go about doing this. One thing I could do is, oh, that's a space. Take everything and shift it down, right? Getting rid of that one space. Oh, the next one is a space. Shift everything down again. Oh, that's another space. Shift everything down again, and again, and again, and again. Right? Does that sound like a good idea? For this one, it's not that big of a deal. You only have 3 spaces, and your string is only 5 characters. So you're only, plus the alternating character, you're only shifting 5 characters at a time. But remember, why are we doing strings to begin with? We're doing them because ostensibly we're storing some data. Think about a DNA string being stored as a string, a bunch of AGCT sequences, right? With millions and millions and millions of characters. And you want to trim out 3 leading white spaces, right? Shift 10 million characters once. Shift 10 million characters twice. Shift 10 million characters thrice, right? 30 million operations, right? Does that sound reasonable? Probably not, right? Now what should have taken a blink of an eye is now taking seconds, minutes, right? Maybe hours, days, weeks, right? Literally weeks, or years, depending on how many characters are actually over here. We could benchmark that later on when we start looking at efficiency, right? That would end up being an order n squared operation, right? You'd end up doing n squared operations. And if n is, say, 10 million DNA sequence characters, right? 10 million squared, that's big, right? And it's not feasible. Right? So let's be a little bit smarter about it. 1, 2, 3 characters, right? Shift everything over by 3 characters, right? I've got 2 pointers here represented by my fingers, right? I'll start at the beginning, and I'll start at the beginning of the actual string here, right? And I will copy this over here, increment this, right? I'm going to keep these as we go along here. So I'm going to need 2 fingers. I'm going to need 2 indices, right? I've already got 1. I is equal to something, and now I need j is equal to something, right? First of all, before we even do that though, first, count up the number of leading white space characters, ... right? So int count, right, is equal to 0. Let's see, while, right, because 1, 2, 3, stop, right? I don't care if I'm at the end of the string here, right? While some condition, I will say count plus plus, right? The condition would be, of course, be that is space of s of I, where I starts at 0, I is equal to 0. I did want to keep that, right? There we go. Well, that's a space, and oops, I am not typing well today. There we go, and there we go. All right. So while the this value is a space, increment count it, and then I plus plus. Right. I will stop right here at the first h. Okay. That tells me that there are 1, 2, 3 characters here. Okay. Again, this is whiteboarding, right? You write out an example and then try to figure out how to go about doing it. Okay. So I've got a count of the number of characters that are white. Well, first of all, are we going to hit the same problem here as we did up here? What if they're all white space characters? White space, all the way to the end until we get to the null terminating character. So what else could we do here? Right? Remember that we already computed the string length. While I is less than n, and it's a space, continue counting it. Right? Wait a second. If it's all white space, guess what? We're done, right? So you could put in a condition here that if you erase the entire string, right, then you're done and return. Right? Okay. And then you get out of doing all this stuff over here. I'll leave it as is though. Right? Let's see. So we'll count that up. Yeah, we'll count that up. I still don't like it though. Well, let me do something a little bit more robust. Well, first of all, this is wrong. S of I, right? Well, S sub I is not equal to the null terminating character. There we go. Right. That's a little bit more robust, right? I like that a little bit better. Why? Because you'll get to the end of the string, right? You might have deleted a bunch of stuff already, even though it was a much larger string before. Now that you've deleted everything, you're only going up to this null terminating character. Okay? I like that better. So now we have 3 spaces here. Right? What should we do next? I want to start one index at 0, and I want to start one index over here, and then start copying, increment, copy, increment, copy, increment, until I get to the end of the string right here. Right. So, where should I start my indices? I'll start I at 0. J should start where? If count is 3, where should it start? 0, 1, 2, 3. Okay. So at count, however many spaces you've got. All right. Now what am I gonna do? While J is going to be tracking this part over here, so when it hits this null terminating character, that's when I want to stop. Okay. So while I don't know S sub J is not equal to the null terminating character, there we go. I will copy S sub J over to S sub I. Oops. Increment both, dot, dot, dot. Right? So S sub I is equal to S sub J. I'm just moving this one over here, right? And then I'm I plus plus and J plus plus. Okay? Now, does that take care of the null terminating character for me? H-E-L-L-O. But the second that I hit this, I break out of the while loop. I need to copy that null terminating character over. I'll take care of that after the while loop here. Right? S sub J is equal to the null terminating character. Now, why did I do S sub J? What is J pointing to at that point? Or, sorry, that is wrong. It should be S sub I, right? Because I was tracking on the left part, right? Copy, copy, copy. Okay? And then return 0. Let's find out if that worked. GCC. Let's go ahead and put in something normal here, though, first. Space, 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 tab, tab, hello. Right. Let's go ahead and put in some, well, let's isolate that test, right? We now know that that first code should not execute. Does it work when we have no trailing white space, but we have some leading white space? All right. Let's run that. I'll just run it by itself. Come on. There we go. All right, so it seems to work, right? A bunch of white space, and then hello, and now that's all been removed, right? Put in an endline character here, there, whatever. Do whatever you want. Put in some space over here. Put in some space after the fact, space, endline character space, right? Let's see if it all works. And by the way, if you are doing stuff like this, sometimes it's helpful to put in like some parameters, or not parameters, but some rails here in order to see that there's actually, because you can't see printed white space, right? So sometimes it's helpful to do that so that you can see that indeed everything was taken out. Right? Looks like it works to me. Again, what are some other corner cases here? What if it is all white space? There we go. All of it is trimmed out. Okay. Cool. Nice little exercise here. How do you do it in Java? So string foo is equal to leading white space, tab, tab, endline, hello. Right, there we go. I want to remove leading and trailing white space from foo. So should we start writing our own function? Nope. Remember, what's the first question you ask when problem solving or in engineering? I've got a problem here. Is it already solved? Right? Be lazy. That's why we program stuff, right? So foo dot remove, not remove dot, what is it? Replace. There we go. Replace the target sequence here with nothing. Right, there we go. And then I need to capture this string bar. There we go. So what I'm about to show you is a regular expression. Right? Actually, we could do it one of two ways. So I want to replace every single space character with nothing. Right? And system.out.println bar. Right? I can do that again. And I want to replace all endline characters instead. course, I can't redo bar. And then I can do it again, and again, and again for tab characters. There we go. There. Oops. Let's put some guide rails on this. Plus, bar. No, sorry. Printf would have been a lot better here. Let's go ahead and replace that, replace that, replace that. All right, and you'll see here that before there's a whole bunch of stuff, right? Before there's a whole bunch of stuff, and still there's a whole bunch of stuff. Dang it! Is it replace? Oh, it should be replace all, right? Let's read the documentation. Unfortunately, each substring of this string that matches the given regular expression with the given replacement, an invocation of this method yields exactly the same result of the expression. Okay, yeah. I don't know why it's not working. That's the way I expected it to work. Replace all spaces with nothing. All right, so we need a regular expression. I think it's S plus with nothing. Let's print it out first. Oh, I guess there is no bar there. So don't quote me on this. Is it? Okay, dang it. I'm going to have to look it up. Replace all white space Java. Java regular expression. I thought it was a slot. Maybe it's, no, it should be white space matching regular expression. There we go. Match white space on its own native character set. Yep, that should be right. Okay. If you want to a full Unicode solution, you'd go with that. But otherwise, that should work. Yeah, I'm not sure why it's not working. Do I have white space over here? Nope. I'm going to have to look this up, but it should be one or more instances of white space. Do I have to surround it with a group? Nope. Darn it. So Java remove all white space from string. Should be a regular expression S. Okay, I need a backslash. A double backslash. Fine. Otherwise, what it was doing, it was looking for literal S's, I think. No, this... Oh, God damn it. Thank you. Keep yelling at me for that. There we go. All right. So anyway, I tried to do this to give you a really, really quick tip of the iceberg introduction to what are called regular expressions. Regular expressions are ways that you can say match any number, right, and replace it. Match any single number and replace it. Match any combination of three numbers, et cetera, right? For example, let me go ahead and move or change this to a phone number, 402-472-5008. That's my office phone number. It doesn't matter. It's public anyway. All right. So let's replace all, like, say, all numbers 0 through 9 with nothing, right? And you'll see that it removes all the numbers, leaving only the two hyphens there. Right? That's a really powerful thing, right? You can replace any single number with whatever you want, right? Replace it with foo. Right? And now it'll have it should. Okay, I don't know why that's doing it, but whatever. Now, what if I only wanted to get rid of the area code instead? I could say 0 through 9, the prefix, I don't know, 0 through 9, 0 through 9. There we go. So what that's going to do is that's going to match any pattern that is any number 0 through 9, followed by any numbers 0 through 9, followed by any numbers 0 through 9. In other words, a sequence of 3 numbers. Now, it's going to take out the area code and the prefix there because, of course, both of those, I keep not saving it, right? Because both of those are 3 numbers, right? And it ends up doing 500 as well because that matches the pattern as well. But if I change this so that it's 3 numbers followed by a hyphen, right, then A literal hyphen probably is what it wants. Nope. Okay. I don't know why it's doing that. Come on. There we go. A literal hyphen. I think it's just a saving problem. I keep forgetting. There should be autosave. I'm going to have to reconfigure this after I leave. Anyway, 3 numbers followed by a hyphen. That's 402, and that's the second one as well, leaving 5008. Right? You can do things like, I don't know, well, what if I want all sequences of numbers that start with a 4? This will match anything that is 400, right? 400 all the way up to 499. Right? And that'll take care of both of these as well. Unfortunately, since they both start with 4, let me show you that I'll change my phone number here to 3. Right? And it'll only take out the first one. Right? Really powerful stuff here. Right? You can go from a simple dot star, right? Replace anything. Right? Save. Replace anything. It gets rid of all of it. Right? Dot matches any single character. Star matches 0 or more occurrences of that character. You can change it to 1 or more occurrences of that character. If you want to remove any 2s, right? There we go. So all the 2s will be removed now, right? But that's just a straight up, that's not even a regular expression. Right? You can go through A through Z, right? Hello. My number is, right? A through Z, I'll replace all of those with nothing. Oops. Oh, okay, not caps here. So I want all caps as well. There we go. There, I've isolated the phone number out of a web scraping application, right? You download a web page and you want to automate the process of collecting everybody's phone numbers so that you can spam them or something like that, right? Well, it's really easy to do with a regular expression here, right? Match anything that looks like a phone number. In other words, 3 numbers followed by a dash, 3 numbers followed by a dash, and then 4 numbers, right? International phone numbers, etc. Anything that looks like a URL, right? All that kind of stuff. So this is extremely powerful, right? And what took us, I don't know how many lines of code over here did we write? Maybe a few dozen, 50 lines of code over here. What takes us 50 lines of code over in C means that we can go ahead and remove all leading white space at the beginning of the string, S, and then non-white space, how do you say not? I forget. Nope, and then trailing white space. Dot star, trailing white space at the end of a string. I'm not sure that this is going to work. I'd be very, very surprised if this works. Space, 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 space. Hopefully it does not get rid of the internal spaces. Excellent. I did it. I'm actually proud of myself for doing that on the first try. That makes up for screwing up the // s earlier, right? So let me walk you through what I just did. The caret matches the beginning of a string. So in other words, whatever sequence I've got right now started at the beginning of a string. Any white space, right? Replace that with nothing, right? This should be where. Oh, maybe I screwed up. Save. Maybe I'm wrong. Oh, darn it. What was the last one that I just did? Oh, maybe it's because I didn't have white space. Darn it. All right. I got a big head. I was not successful in doing that. So we could do this though. A through Z, 0 through 9, and white space, star. There we go. I did it. And I saved it. All right, let me walk you through that. So that's the beginning of the string. Match any white space at all in the front of it. Then match anything that is, A through Z, caps, lowercase, 0 through 9, or whatever. Right? I'm not sure why it's matching this, but it is. I'd have to look at that again. 0 or more occurrences of it. Oh, nope. I don't know why it's matching the hyphen. And then 0 or more occurrences of it. Leave it alone and then replace it with this. And then any trailing white space. The $ at the end matches the end of the string. Right? So that should, yeah, I'm actually surprised that that's working. I'm not sure why. I'm going to have to investigate that further. Anyway, I wanted to show you this as the tip of the iceberg of what you can get into with regular expressions. We won't revisit them, and they're not going to be necessary or required for anything that you do. But usually if you're trying to do something fancy, like remove all leading white space, all trailing white space, there's probably a regular expression that you can find to do it. And if you just search around for that regular expression, you'll find it. Right? Like, for example, I want to match all email addresses. Right? It's going to be a really, really complex one, but you can find it, and then you can use that to scrape for email addresses. Right? Okay, so Java, you have a lot of built-in stuff that you can use, right? So Java, so C, complex, right? Java, easy, right? Or you may want to look up a regular expression. There are also regular expression builders online. What I want to do with the last few minutes here is start processing actual data. So let's come over here. I'll leave that in there and eventually copy and paste that into your notes for you if you want it. Otherwise, here's some data. This is a very special format of. It's not a very special format, but it's a common format of data. Right? It's called CSV data. Right? So that data obviously represents my first name, last name, NUID, my city, state, and my office number over in Shore. Right? How are each one of those pieces of data delimited? By a comma separated value system. Right? That's what CSV is. Right? So CSV data is comma separated value data. Right? Comma separated value data can be processed by looking at each token. Right? Each piece of data is a token, and you can separate them. Separate them by tokenizing them. That's the operation. So that's the operation that I want to show you really quickly before we leave here, and then we'll go ahead and revisit it on Friday. Right? To do that, you have this nice little function called strtoke, right? For tokenize. Okay? strtoke can be used to tokenize a string. Right? The function, you provide the delimiter, the string to tokenize, the string to tokenize, and then the delimiter. So delimiter is the thing that separates the data. In this case, it's CSV. It doesn't have to be CSV. There are TSV files out there. What do you think the T stands for? Tabs, right? Tab separated values. Right? This is a very common way of saving stuff. For example, you can dump an Excel file with a bunch of rows, right, and a bunch of columns. You can dump that to a CSV file. In fact, if you ever receive a CSV file and you double click it on especially a Windows system, you're going to it's going to open up in Excel, right? Because it's going to think, okay, well, you want this in Excel because it's CSV data, right? So strtoke. I'm going to pass in the thing that I want to tokenize, so CSV data, right? And I want the delimiter. Again, the delimiter doesn't have to be a space. It could be a space, it could be a tab, it could be whatever you want. But I want it to be a comma because this is comma separated values, okay? It returns a pointer to the next token, ... So I need to capture that. Char star token, right, is equal to this. Now let's go ahead and print that out. Token is equal to %s and the line token. There we go. And let's compile this. Oops. What's wrong? Int. Oh, sorry. It's not a single character. It's a, there we go. I had to remind myself about that. There we go. All right. So let's take a look at the first token. I'll come back and explain this probably on Friday. Well, a quick explanation is it needs to be a string because you can have multiple tokens. You can tokenize on a comma, a tab, and a lowercase o if you wanted to. Right? We'll play around with that on Friday. But otherwise, let's go ahead and look at the process, right? So there's the first token, Chris, right? What's the next token? My last name. So we need to tokenize it again. Token is equal to str toke of CSV data, right? And use the same delimiter here. Now this one's not going to work. It's actually going to print out, I believe, Chris again. And that's because you use it differently on your second. Instead, pass null. For example, instead of passing the string, I'll pass null instead. Right? Now, the reason that it worked before was because, well, what is CSV data? It's still the string that starts with CHRIS, my first name. So you're saying, I want to tokenize the same string at exactly the same spot as before. Right? You're not getting anywhere. You're not getting to the next token, the next token, the next token. In order to use this, you need to properly and tokenize the same string on subsequent tokens. You need to provide null as the next argument. Now this should work. It's going to print out my first name. Come on. There we go. And my last name. There we go. Let's keep going. Cut, paste, cut, paste. How many tokens were there? 1, 2, 3, 4, 5, 6. So I think I did that. 1, 2, 3, 4, 5. One more. There we go. There. Because I knew how many tokens there were. What if I don't know how many tokens there are? So what if I go one more? So there's not another token there. What's it going to print out? Null. What does that tell you about this value right here? When there are no more tokens, it returns ... null. That suggests I don't have to do copy, paste, copy, paste, copy, paste, copy, paste, right? How could I have done it instead? So what kind of a loop would you want to use? A while, right? While token is not null. And in this case, since we've already tokenized it, let's go, we've already printed it. So let's go ahead and get the next token, print that token, and then be done with it. All right. I'll go ahead and leave this up here so that you have it in the notes. There we go. Oops, we went one too far. So we get null here. We should print it up here. So let's print that, and then we won't print the first one. I think, right? Yep, there we go. All I had to do was change the sequencing around. So now if you have any data that's CSV data, you can go ahead and process that and use a while loop to tell, am I at the end of this processing of data yet? Right? And that's str token. One really, really quick example in Java. Again, to demonstrate everything with strings is way easier in Java. Guess what? I can get, we're over time here, but it'll be foo.split. Right? And it returns an array of tokens. We'll pick it up there on Friday. Right? So one function call, and you don't have to worry about it.